All right, so we're taking a look at algebra sections 2.6 and 2.7 today. This is going to take us through the end of chapter 2 here. So we're going to look at, first of all, here at dividing real numbers. Okay, so when dividing real numbers, we're going to look at dividing as multiplying by the multiplicative inverse, okay? Multiply by the reciprocal. Something that you'll hear me say a lot in class is keep, change, flip. Keep the initial guy, change the middle sign to multiply, and then flip the other one, okay? Another word for multiplicative inverse is the reciprocal, okay? Is the reciprocal. All right. So the first thing we're going to look at is finding multiplicative inverses. And so I gave you a list of numbers here, and your task is very simply to find the multiplicative inverse, or you could think of it as the reciprocal. So the reciprocal just means flip-flop the top and the bottom. So it's going to be -7, flip-flop -3 over 5, flip-flop b over a, flip-flop. Now this one you might want to change into 16 over 5 if you want, okay, as a improper fraction. And so the reciprocal is going to be 5 over 16, and the reciprocal of 9 is just 1 over 9. Okay, so example 2 says find the quotient. Okay, and here's what we're talking about in terms of thinking of this as multiplying by the reciprocal. Instead of thinking this is 18 divided by -3, which we can, and we can do that easily, we know that that's -6. But since we're familiar with that, let's look at this example. So we have 18 times -1 over 3. That's the reciprocal. This is 18 over 1. So when you multiply two fractions, you multiply straight across. So 18 and -1 makes -18 over +3, which is the -6 that we just talked about. Okay. Again, multiplying by the reciprocal may not always be the best method for dividing, but it's consistent. It always works. Okay. So for part B, you have -16 times the reciprocal. Multiply straight across. At this stage, if you recognize that you can cancel this 8 and this 16, you can do that. If you don't recognize that, it's fine. You're just going to be multiplying bigger numbers. So now I have -2 times -3, which is +6, over 1. That's just 6. Okay. I have -2 over 5 times 1 over 18. I recognize that I can cancel out 2 and 18. And so really what I end up with is -1 over, I have 5 times 9, which is 45. Okay. And then finally, the last example here, -3 over 8 times 10 over 3. Okay, the 3 and the -3, this is -1 and 1. This guy will cancel for 4 and 5. So all I'm doing is simplifying. I'm just finding guys on top and bottom that I can cancel. Okay, so on top I have -1 and 5, which makes -5. On bottom I have 4 and 1, which makes 4. All right, so again, I went through that section quickly with the understanding that if you're confused, you can pause, rewind, replay as many times as you need to in order to get a legitimate and adequate explanation of those examples. All right, example 3 says that, let's see what we got here. All right, so in example 3, story problem says, Andy recorded the low temperature each night at his home during January. Over 5 consecutive nights, he recorded the temperatures. What was the mean low temperature at his house for these nights? So the mean means average, and average just means add up and divide by the number of things you have. Okay, so we have -2 plus -10 plus +6 plus -1 plus 2, and there are 1, 2, 3, 4, 5 of them divided by 5. All right, so I have, let's see here, -2 and -10 is -12, plus 6 is -6, plus -1 is -7, plus 2 is -5 over 5. So -1 degrees Celsius was the mean low temperature, was the average. Okay, was the average. All right, the next section we're going to look at is just simplifying expressions that involve fractions. Okay, and again, hopefully this will help you get over your intimidation regarding fractions for most of you. So you'll notice in this first example, right, we're going to take this expression, we're going to rewrite that. All right, we're just going to break it up into each part, rewrite it, and then simplify each term. Okay, so in part A, when I break this up, I get 40x over 8 plus 32 over 8. And when I simplify that, 40 over 8, that's 5. 32 over 8 is 4, so I have 5x plus 4. Okay. Again, break them up first. Negative 10z over negative 5 minus 20 over negative 5. All right, so I get 2z, right, because negative 10 over negative 5 is 2z, minus negative 4, which is just plus 4, 2z plus 4. And finally, part C, rewrite each expression, so negative 6y over 3 plus 18 over 3. Negative 6y over 3 is negative 2y, and 18 over 3 is positive 6. All right, so that's all we're doing. Just when we're wanting to simplify, rewrite, and then cancel out what you can. Okay, rewrite and simplify. All right, finding square roots. All positive real numbers have two square roots. Okay, a positive square root and a negative one. So for instance, 5 squared equals 25 and negative 5 squared also equals 25. And so we would say that 5 and negative 5 are square roots of 25. And since those are nice integers, we would call 25 a perfect square. Okay. The square root symbol is also known as a radical symbol, and the number underneath the radical symbol is known as the radicand. All right, and it's spelled radicand. Again, you don't really have to memorize that, but it's just a mathematical language for the number underneath the square root. Normally, if we want the number underneath the square root, I'm just going to say the number underneath the square root. I probably will not use that terminology very often. Okay. It says evaluate without a calculator. Okay. So it's the opposite of the square root of 9. Well, the square root of 9 is 3, and so the opposite of that is negative 3. The square root of 25 is 5. Okay. C, plus or minus the square root of 64. That's plus or minus square root of 64 is 8. The opposite of the square root of 81, which is 9. And square root of negative 16, can't do it. Okay, you cannot take the square root of a negative number. All right, cannot take the square root of a negative number. And part F, the square root of 0 is just going to be 0. Okay, so square roots should be something, you know, the basic ones that you're familiar with. What happened in E and F, clearly E, no solution. You can't take the square root of negative, and F, the square root of 0 is just 0. Okay? It says find the square of a number. Okay? That's pretty straightforward. The square of a number just means multiply it by itself. So 14 times 14 is 196. Okay? And as you get comfortable with these things, you're going to be able to just know these off the top of your head. Okay? I'm not saying you should right now, but you will get there. Okay? 16 times 16 is 256. Okay? Again, not going to expect you to necessarily be there right away, but the more we do this, the more comfortable you're going to get. Negative 7 times negative 7 is positive 49. 9 times 9 is 81. Negative 2 times negative 2 is positive 4. That's just finding the square. Okay? And here are all the examples here of your perfect squares. Okay? 10 squares, 100. And obviously, there's way more than that. You can keep going and going. But those are the ones that really you're going to be expected to know in this class. You know, you should also know that 11 squared is 121. 12 squared is 144. And then beyond that, probably not so much. Okay? So this next example says, what two integers would the square root of 32 be between? Well, we know the square root of 25 is 5, and the square root of 36 is 6, and 32 is clearly between 25 and 36, so that would be between these two integers. All right. Square root of 48 is awfully close to the square root of 49, which we know to be 7, and so the opposite of the square root of 48 is going to be very close to negative 7. Again, just getting you familiar with these perfect squares so that when we start working with them in class, we're not having to go back and revisit. Okay. It says tell whether each of the numbers is real, rational, real, irrational, an integer, whole number. None of them. List all that apply. Okay, and we're going to kind of use these abbreviations. I'm going to do the first few and then leave it up to you. We've already done this in class a little bit. The opposite of the square root of 25 is negative 5. Okay, that's not a whole number, but that is an integer. Okay, and that is a real rational number. Okay. Skip over to part C. Square root of 30 is not a nice perfect square. Therefore, it is a real irrational number. All right. And again, that's kind of what we're doing there. Part D, since it's a square root of a negative, is going to be none of them. Okay. It's an imaginary number, which we're not going to really talk about in this class, but there are things such as imaginary numbers that we can work with. But again, we're not going to do that in this course. Or at least in the near future. So example 8 says you plan to use a square section of a park for a small outdoor concert. The section you have an area of 1450 square feet. You have 150 feet of rope to use to surround the section. Do you have enough rope? It says square. Okay, draw a picture. You know what a square looks like. It's the same on each side. Okay, call this x, call this x. The area of this square is given by x squared. Okay, so what we can do is we can figure out how long each side is because we know that x squared, the area, has to be 1450. So I take the square root of 1450, all right, and when I take the square root of 1450, I get 38 roughly. This isn't exact. All right, I get x equals roughly 38.09 or 08, I should say. And so the question is, do you have enough rope? Well, I have to do all four sides, so I'm going to multiply that number by 4. When I take that number and I multiply it by 4, I get 152, roughly. And that number is clearly bigger than 150, so the answer is no, I do not have enough rope. All right, so that's just a kind of a story problem involving square roots. Okay, so again, the idea, we're going through these sections quickly because we feel like you guys should already have a solid foundation with most of these ideas. If that is a misconception or if there's an idea that's giving you a hard time, as always, come see me in the mornings or just bring the question to class and we'll answer it then.